So hey everybody, good to see y'all again. If this is your first live demo or not, it's a pleasure to have you here. We're going to be talking today about sort of an open source data stack that was built with sort of ingesting and allowing us to analyze data about open source communities in mind. So that's what we're talking about today. First, just like a little bit about me, some basic background. I'm a data engineer. I'm also a developer advocate at Preset. I have a background in scientific research, software development, and data engineering. And at Preset, one of the things that I get to do is be really focused on understanding what makes open source communities tick. And part of the effort to understand open source communities is we need to actually get data about open source communities. And so as part of that, I get to build cool open source data stacks, design reference architectures, and share knowledge, which is basically what I'm trying to do today, is just kind of talk about this data stack and share some knowledge and maybe get some good questions which we can answer. So quick agenda for today, just like rough. First, we're just going to get a quick overview of the technologies involved. So this data stack is built on Superset, Airbyte, DBT. We're going to talk about each one of those tools briefly, what they do, how they fit into the stack, and then kind of like the overall architecture. I'm going to give you kind of like a Charlie and the Chocolate Factory like guided tour of the inner workings of this thing to highlight a couple of interesting features of these tools, and also to show you how easy it is to like add things to like add repos and other sources of information to this data stack. And then afterwards, we're going to do a little bit of dashboarding on this community data. We're going to talk about like some features of Superset, some things about what makes a good dashboard, and then we're going to take questions. So that's hopefully everyone has an opportunity to learn something. And yeah, let's get going. So first, everyone's favorite, for those that maybe are new to the Superset community or aren't familiar with Superset, Apache Superset is really the thing that we're focused on oftentimes at Preset. It's an open source data visualization and business intelligence software. It works with just about any SQL speaking data source. It allows you to cache queries and has a lightweight semantic layer, so it can be very performant and minimize the queries against whatever your data source is. We're sort of supporting an ongoing migration to Apache eCharts, which includes a number of time series focused charts, geospatial charts, and other like really cool kinds of visualization. Also, we have some in-chart analytics, which includes things like Facebook's profit package. So you can do some analytics at the BI level, which is really cool. I like that feature a lot. And then also we have kind of an open source plugin architecture. So Apache Superset, generally speaking, is pretty extensible. And for a lot of the organizations that use Superset, its extensibility is part of the reason why they favor it over other options. So that's Apache Superset. I presume most people here are like at least roughly familiar with what Superset is and what it does. But let's talk about the other tools that are part of this stack, because I think that maybe they're a little bit less well known. The first one I want to talk about really briefly is Airbyte. So I've talked in the Airbyte community about how I'm using Airbyte in this project before, and so I'm just going to be brief about like exactly what it is and what it does. But essentially, it's an open source data integration tool that focuses on extracting and loading data. So think kind of like Fivetran. It has a containerized architecture and has many data sources and destinations. It provides like automatic, what they call 80-20 normalization, which I find to be very useful. So it'll basically take its best crack at like normalizing the data that's coming out of SaaS APIs. It's not always perfect, but oftentimes it gives you like most of what you need to sort of minimize the number of transformations that you have to build on top of the base data. So that's really cool. Also, one feature that they added fairly recently, which I really, really appreciate, is that if you have data coming from a SaaS API where you have like tables and some columns in that table are in like a JSON format, you have like some kind of nested data structure inside of certain columns, it'll take those columns and like automatically unpack them into like child tables that are connected to the parent table, which makes it really easy to like rejoin that data back into a big flat table, which is oftentimes where you want to start when you're doing transformations of data. Also, recently they added the ability to have your own sort of like configurable normalizations and transformations through DBT. We are using DBT in this project, but we're not using any of the custom transformation of data using DBT through Airbyte. We're using DBT on its own as part of the stack. And also, they recently added some support for Kubernetes, which is really important if you're going to think about using Airbyte in kind of like a production setting or like sort of like in a modern cloud data platform, which is often built on like a lot of containerization, oftentimes with Kubernetes. So that's Airbyte. We're using it for ingesting data, and we're going to kind of tour that tool really briefly soon. Also, we're using DBT. DBT may be a little bit more well-known. It's an open source data transformation tool, fundamentally. It abstracts transformations of data as models, they can be sort of chained together into a directed acyclic graph, kind of like Airflow can work with directed acyclic graphs to allow execution of complicated tasks, similar sort of thing. But in this case, it's like transformations of data. And all of that can be under source control too, which is really, really important for moving data engineering away from being this kind of ad hoc, strange, arcane sort of discipline, more towards it being more like software engineering in a lot of ways. I think that's a real trend that's happening in the world of data engineering right now, is to make data engineering more like software engineering in the ways that software engineering has become mature with tests and continuous integration and things like that. Also, speaking of which, it enables documentations and tests to be built right into the project, which is super helpful. You can test things both at the schema level, but you can also build logical data tests into the testing framework. So that's really cool too. Also, it has powerful macro and Jinja templating functionality. So it basically, I'm going to show you actually some of those, but it lets us create macros, which are super useful when working with complicated base data. So I'm going to demonstrate some of that. Also, it encourages, and I feel like in some ways sort of defines data development best practices. It's not quite the same, but I sort of compare it to the way that Git, when it first came around, sort of eventually defined a set of best practices around software development. I feel like DBT sort of riffs off of a lot of the ideas that were incorporated originally into Git, and sort of builds a data development best practice, or at least one vision of what a good data development practice is like. And I feel like that's really needed right now. And I find that to be a very attractive thing about that tool. So that's the parts of the stack. That's what we're going to be talking about today. I want to talk a little bit just broadly about what are the goals of this project. So why am I doing this? One reason is that as a developer advocate at Preset, it's really important that that I and we also as a company understand the needs of the Apache Superset community, so that we're able to address them and best serve that community, right? Our company is built on Apache Superset, and it's really important that the Apache Superset community is something that continues to thrive and grow. Also, we want to be able to identify and recognize community champions and new contributors. So people who maybe are pulling a lot of weight, answering questions or doing things like that, tackling issues. New contributors, people who maybe want to contribute to the project or have opened their first PR, but maybe need a little extra push to help them get over the finish line for having their contributions merged into the project. Also, we would like to be able to identify our own employees who are making a difference, so that we can recognize them. So we have engineers. If you've been around the Superset community, maybe you've had a conversation with Ty or Beto, right? There's folks that hang out in the community a lot, and it's really nice to be able to really track and quantify their impact as well. Also, I think the ability to compare open source communities is really interesting. And this is kind of a longer term thing, but I'm sort of interested in understanding better, what are the common factors that sort of drive or hamper growth of these communities? What are indicators of overall community health? How do different kinds of open source project differ from each other, right? DBT is an open source project that is not there's different kinds of open source project. I don't want to go into excruciating detail on it, but basically it would be really interesting to understand how those different kinds of open source project grow differently over time. Also, I would like to make this be sort of a reference architecture that other organizations can take and kind of set up on their own data infrastructure and use to get information about their own communities. And also, it's just a general way to learn things, both about open source software and also myself personally to learn things. So these are sort of the goals of the project. The architecture looks something like this. So we have Airbyte that's basically pulling data from a number of different APIs and is loading it into a staging environment. And then DBT is performing transformations on that data automated by Airflow. And then the community data model essentially is built by DBT and provides a schema that's ideal for visualization in Superset and Preset. Also, here on this drawing, you see Amazon RDS, but the reason it's up there is because it's actually swappable, right? You can store this data in whatever data source you want with minimal modification. I recently kind of migrated over from using like a Postgres RDS in AWS to using BigQuery, which is one of the things that our organization uses. So yeah, it was actually not too painful a process to move everything over. And I think you could probably partner this data stack with like whatever data store you were interested in. So now we're gonna go on a quick little tour here. So forgive me if something goes off the rails here. This is like pretty involved. So let's just keep our fingers crossed and hope that nothing goes horribly wrong. So I'm sharing my screen right now. First, let's talk a little bit about ingestion. So we're going to kind of like go through the stack. So we have this tool called Airbyte. This is kind of like what the interface looks like. We have a number of connections set up. We can set up sources. We can set up destinations. I wanted to kind of showcase like how easy it is to add a new data source to this stack. So like, suppose that I was interested in tracking a repo. So this is an open source software project that I've followed for a while, and I think it's kind of interesting. Like it sort of fits some of my hobbyist interests. And so I want to add it to I want to add it to what we're tracking. So we're just going to set it up. I've already entered my access token here to avoid any embarrassing displays of tokens during live demos. I'm going to go ahead and just set the source up, and then it's going to ask where I want to put this data, and I already have my destination set up. So this is the BigQuery instance that I'm loading data into. And we're going to just go through this process here. It's going to check, make sure that everything is good. It's going to fetch the schema. We're going to give it a prefix that's consistent with the other prefixes in this base data. It's important to do that because of the way that the DBT macros work, and I'll show that off in a second. But we're going to call this GitHub. Let's just do this. Boom. Cool. So actually, let's choose a better name. Let's go. That's the proper name. Okay, and then these are the streams from the SaaS API that we want to sync. I'm just going to leave them all selected. This is a relatively small repo, so we can have all of these selected and have it not take a ridiculous amount of time. And then we can set up a sync frequency. I'm just going to say once every 24 hours. We're going to hit setup, and then we're just going to let this run. It's going to basically set the connection up, which it's doing right now, and then it's going to start running a sync, which I expect to take about 10 minutes. So we'll come back to this shortly. In the meantime, let's move over and talk about how the data is actually being transformed. So Airbyte is extracting and loading the data into basically a landing schema. Let's go over here. So this is inside of data grip, and you can see that we have a base schema. And this is basically where Airbyte puts the data. So you can see that we have essentially all kinds of different repos loaded in here, and they follow a certain consistent naming pattern. And the reason that's important is because we have a number of macros here, the most useful of which is probably this one. And what it does is basically it allows us to specify out in our main DBT project file. It lets us just specify what repos we're tracking. And so since I'm adding the data for this project, let's go ahead and add the repo that we just added base data for. Right, and then what's going to happen is this macro is going to take this table string and is going to insert it into a pattern, which is GitHub _ table string _ table name. And then basically is going to use this to just automatically stream all of the data into our system, not streaming in like the data engineering sense, but you'll see in a second. So this sync is still running. When it's done, we'll come back here and I'll run DBT. I'll show you what that looks like, and then we'll see the data just kind of appear in our visualization. So I'm trying to think, is there anything else I want to show about the transformations? I don't think so. Yeah. So we have basically our transformations organized by what they do. So our core schema is where all of our final transformations, like these are the final tables that we're trying to visualize. We have a staging schema that has basically a substantial number of transformations on the base data, one for each stream coming out of the GitHub API. And of course, we're taking the data from all the different repos and we're rolling them together using the union all macro that I showed before they end up in these tables. So That's kind of how the transformations work. I kind of expect that there's going to be some questions about how we're doing transformations, and I'm actually really happy to dig into the details and answer those questions. But we'll just save it for the end. Feel free to ask them though, and we'll come back to them when we're done. So the really important part here, if you're not a data engineer or you're not familiar with DBT or you don't care about DBT, is just that you can use DBT to have a source controlled repo that defines all the transformations on your base data. And then it makes it very easy to run those transformations and then validate that those transformations are being run correctly, which ultimately gives you confidence that what you're visualizing is real data that's actually useful. So speaking of which, let's go over into Superset. So here I am. This is Preset Manager. Each one of these is like a Superset workspace, and this is the one that I've set up for this demo. So I'm just going to click this guy, and as it opens up, we will see that there are some dashboards already made. So I want to do a couple things with this part of the demo. First thing is I want to showcase some of the things you can do on top of this base data. So I'm going to show a couple dashboards really quick, and then I'm going to do a little bit of quick dashboarding just to show something really fast, and then we'll kind of bring it back for questions. So my colleague Srini was very nice and decided to help me build a really cool dashboard. I want to highlight some stuff about this dashboard. So this is a dashboard that's purpose is particularly to track GitHub issues. If you haven't been around the Apache Superset community, you know, or you don't know, I guess, that there has been a growing number of open issues in our repo. And one of the things that we're trying to do is get a grip on that so that we can make sure that these issues are basically getting touched, they're getting addressed, and ultimately, hopefully, they're getting closed. So basically, we're looking at issues from 3 different repos right now, and we're showcasing one of the cool features that was added to Superset fairly recently, which is dashboard native filters. So this is a filter that lives out at the dashboard level, and it lets you select the repo, and it affects everything that's going on inside of this particular dashboard. We also have tabs. This is a tab dashboards. We have different charts on different tabs, which is, I think, a really great dashboarding best practice for like organizing charts in a dashboard. So first, let's just kind of go through these really quick and talk about what these are. So this is the total number of open issues across all repos, or all 3 of these repos, rather. We have open versus closed issues by creation date. So you can basically see like when were issues closed relative to when they were open, like how many issues have been open, how many issues have been closed per time period. We have open versus closed issues by creation date. This is really actually, I guess, what I want to highlight, which is that, you know, issues that are open more recently are open, like they stay open. Issues that are older are more likely to be closed. So it's basically showing that there is a persistent backlog of open issues that haven't been addressed. But as we go to more recently, we have more issues that have been open recently that are open and not closed, which makes sense. We can look at kind of like a fire hose list of issues. So here we have a table chart type that basically shows us, we can configure it to show us different amounts of entries. We can search these records with a search box, which is super handy. And it shows us like, what's the repo name? When was it created? When was it updated? There's some kind of interesting time series data in here too, which is kind of it's going to be interesting to explore. We have titles, we have bodies, pretty much anything that you would want to see about these issues. And we can also scroll to the right to see the ID, whether the author was a contributor or just a member, like who the user actually is that opened the issue, things like that that are, things like that are particularly useful. Also, like, let's look at this one. This is kind of an interesting one. Total open issues greater than a month. So this kind of like really highlights what is the backlog of issues and how has that backlog changed over the last couple of years. You can see that our backlog has begun to grow pretty fierce. You can also see that there's a little dip here in 2021, and I believe that this coincides with the time period where Preset kind of did like an issue bash. Like we went through and tried to clear out a bunch of issues, and I think there's going to be probably more of that in the future. So pretty interesting. We can see stuff like that. We can see distribution of days open. So in general, how many days are issues open? In general, how long does it take us to close issues? Another fire hose list, but this time it's focused on issues that have been created greater than a month ago. We can sort by the oldest issues. We can sort by the interest in the issue, so the total number of comments that the issue has, which maybe unsurprisingly, some of the older issues have a lot more comments, but these issues are still open, so they're worth looking into. Anyway, so I just wanted to highlight, like, this is the sort of thing that you could build. I don't think that, by the way, this is like very work in progress. I don't think this represents like a final good issue tracking dashboard, but it's sort of just designed to demonstrate like what it is that the data that's coming from this stack enables. So I want to show just like a couple other things too. More generally, if we're interested in like charts that pertain to the community as a whole. So these are some older charts, but this is showing data that's from Slack and from GitHub. So we're able to keep track of like who is active in Slack, who is best at answering questions in Slack. So like this is referring to people who are responding to questions that are in certain channels that are designated specifically for questions. Like who are the people that are most likely to respond to something that was posted in the questions channel in the Apache Superset Slack, right? So this lets us see the people that are really active, the people that are really active in the more support-oriented channels, general Slack activity, how the number of different Slack users are distributed across the Slack channels. And then for repos, we can see who are the all-time committers, who are the 90-day committers, what do the stargazer like, what do stargazers look like over time? Like if you're an organization that's trying to work with an open source project, it can be kind of cool to like see how the stuff that you're doing has an impact on the attention that the project is getting. So in this case, like I think stargazers is like a pretty, like looking at the gain or change in stargazers over time is kind of like a good approximate measure for how much attention the repo is getting more broadly. And you can kind of like correlate these things with events that you hosted or things that you did that might have brought attention to the repo. So these things are very useful if you're in developer relations, and maybe more broadly useful if you're the maintainer of an open source project and you want to just better understand like what's going on in your project, what's making an impact on the number of people that are using it or are following it, et cetera, et cetera. And yeah, so that's what that is. And then I want to just highlight a couple things. I want to just make a chart real quick and show something. So we're going to go over to data and we're going to go to data sets. And in data sets, you can see these are the tables that are coming from my BigQuery. I can very easily, wrong one. I can very easily filter by database, and you can see. You can also see that Srini has created a virtual data set to support one of the charts that he made. So a virtual data set is something you can do in SQL Lab that basically allows you to define a SQL query on top of a physical data set that's in your data source, and then perform some transformations. You can rename columns, you can generate new columns, you can recast data types, you can do all kinds of things that are actually really useful if you are an analyst who knows a little bit of SQL and you're trying to basically enrich your data just a little bit more to be able to display it a particular way with a certain chart. So virtual data sets are defined in SQL Lab and allow you to do that. By the way, the way that you create a chart from a virtual data set is once you create it, you just come over to data sets and you click it here. So that'll take you into explore mode where you can make a chart based on that data. But I want to look at stargazers. So I'm gonna pull up the stargazers. And then we're going to pick a chart type, and I want to do kind of a big time series chart. And there's a couple things. So one thing, a lot of people miss this. This is a question that comes up a lot. Is like, oh, I have a time series chart and I have a time column, but for some reason, like I can't get it to display. Like I can't get it to show. And there's two reasons why that might be. One is that the data type should be a timestamp and not a string. Another thing is that is temporal should be checked for that column. So star DT is a temporal column, and we need to check that it's temporal. We can just save that. So we make that little edit to the data set in Superset. And then now that that's done, we can go ahead and make a chart. So we have a time series chart, metric. Let's just take count. Let's group by repo. Save. And I think that should do it. Fingers crossed. Oh, wow. Apache Kafka, or no, that is Superset. I was gonna change the colors on me from the last time I generated this chart. Yeah, so basically this is when we started tracking data for Apache Superset, and you can basically see over time. Let's actually kind of like zoom in. I want to like sort of change the time window here. So let's look at like just 2021. So let's say like last quarter maybe is like a rough approximation. Not really. This is kind of like midway through Q2, but yeah. So this lets us kind of see if there's any events that are interesting that maybe have affected open source more broadly. Like Kafka is a top level Apache project. So is Superset, and so like maybe there's things that are happening that are bringing attention to both Kafka and Superset. We can ask questions based on this data about what's going on in each of these communities, stuff like that. Also, predictive analytics are an option, although I would not apply predictive analytics to this particular time series. I don't think that it would give you something that's super useful. Yeah, so really easy to make charts on top of this data in Superset, and generally speaking, this data is pretty rich and is useful for trying to get insights from what's going on in different Superset communities. I hope to kind of like showcase some of those insights maybe later in the summer once we've built out more analytics on top of this data. But today's live demo was really more about kind of like the stack itself and how you could interface with the stack in Superset. Speaking of which, I think that our thing should have finished. Yep. So we've synced some records from this repo, and now we've added it to this. We've added it to our DBT project YAML file. So right down here at the bottom. And now all we have to do is DBT run, and it will basically generate all the views that are built on top of this base data, and then ultimately generate the final tables. It takes about a minute to run because I'm running it single threadedly, but this DAG is very wide, so you could actually run many threads at once if you wanted to without any difficulty. And then DBT has some other really cool features too, which I want to just like show off super briefly. We're almost out of time for the presentation part, but one thing is that it like generates documentation for your transformations for you. So it has this feature that says like DBT docs generate. You do this, it'll take like a couple minutes, but basically it'll generate I guess I already built a catalog earlier, so it remembers, and then DBT docs serve, and it'll start a web server, and in this web server you can see the projects, you can look at the models. If the models have documentation attached to them, you can see what the documentation is, get estimates of the size of the table, things like that. You can also look at a DAG view that basically if I select like something, I select something from the base data, which would be like, there's, oh, here we go. You get something that's a little bit more DAG-like. There's also a way to view a DAG for the whole project too. And I think actually the way that you do it is you do full screen and then you say, select, just like remove the selection and then update graph. I think, yeah, it shows you your whole project. So you can see how the different tables are tagged together. You can see that a lot of the base tables are not connected to anything that are surfaced in like the BI layer yet. But that is because this is a work in progress, and I'm still working on this project. So that's pretty much everything that I had on the agenda. I would be really happy to take some questions. And also, like more generally, I'm really interested in learning specifically what kinds of questions do people have about open source communities? Like, what is it that you would be interested in learning about your own open source community? Or yeah, if there's stuff that I didn't talk about or didn't showcase today that you would be interested in like learning on this data, it would be cool. I would like to actually build some transformations for those things and build some charts and build some dashboards and like kind of build this out into something that's really full featured. So yeah, I'm going to stop sharing my screen, and I think that we are open